Now let's try to solve this problem, remove duplicates from sorted array 2. So given an integer array now sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it's impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array. Nums more formally, if there are k elements of removing the duplicates, then the first k elements of the nums should hold the final result. It does not matter what you have beyond the first k elements. Now this paragraph just doesn't matter if you are going to code it in Python or a similarly capable language. Return k after placing final result in the first k slots of nums. Do not allocate extra space for another array. You must do this by modifying in place with the O1 extra memory. So basically, if you have seen my previous video, so this is the previous problem, remove duplicates from sorted array. This is very similar to this problem. So basically, in the previous problem, we were supposed to remove all the duplicates of sorted array. Here, this array is also sorted, except instead of one occurrence, we will be leaving two occurrences of the duplicates. So let me explain this properly. So we have solved remove element and then remove duplicates from sorted array. Now we are going to be solving remove duplicates from the sorted array 2. And so this is the okay, it didn't paste properly. Let me anyways, so we do have the correct. So we have the input, which is 0 0 1 1 1 1 2 3 3. In the previous problem, we were supposed to, this array would have been 0 1 2 3, but that was the previous problem. Now it would be 0 0 1 1 2 3 3. So we're allowed to have one extra occurrence of the array of each element. So how are we going to solve this? So shall we use the same logic that we had used in the previous two problems? So we were just comparing with the value in each iteration, and then it was just very simple and minimal algorithm. Shall we use the same then here as well? Unfortunately, you could come up with a similar logic, but it may take some time. So now you could also use hash map for this, but that would be too much. That would be an overkill. So we will still be using two pointers technique. So this is still a two pointers technique problem, except we will be using a slightly different method from what we had used before. So let's first try to visualize this. So now we will only, so in previous two problems we did use Write it one more time. 0 1 1 1 1 2 3 3. In the previous problem also we had used I and k, so here also we'll use I and k, and I will be here, k will be here. We'll start from here. Now the previous you will only put, so let's say so we will only be putting the elements into the array if the number of occurrences is less than 2. So 0 did not occur more than 2 times, so we are putting 0. So we are at this index. Now I will move on to the next one, and then it did count the occurrences of 1, and it was not greater than 2, so k will be coming here and we'll be putting the 1 to move to the next pointer, to the next element. And even now the number of occurrences of duplicates is still 1, because okay, now it is 2, but it was 0 before. Anyways, so we'll also be putting this here, 1, k comes here and puts the 1. Now we go here, but now the number of occurrences of 1 is greater than 2, so we will not be including this, considering this 1. So we'll move on. So now also the number of occurrences of 1 is greater than 2, so we'll move on. So is this same as the previous element? No, this is a new element, and the number of occurrences of this is still 0. So k will move 1 pointer ahead, and we'll be including that. Moving on to the next one. Is this same as previous element? No. So number of occurrences is 0, and the duplicates it has is 0, so we will be including that here. And k moves 1 step ahead, I moves 1 step ahead, and it is same as the previous one. Yes, the number of duplicates is still 1. This is the only duplicate that we have, so we will be also including that. So what is the size of the k now? So after this I will go out of bounds, and k will also increase by 1, making it 1 2 3 4 5 6 7 7. That is what we need to be returning, and anything else does not matter. So this is the problem. Now let's try to code this. So as you saw, we were starting from index 1. So k is the size of the array without more than 2 occurrences, and let's initialize doops to 0, and so since we are starting from index 1, previous element would be nums of 0. So let's start the loop from I in range of 1 to count of nums. Now if and only if the current element was same as the previous element, will you be increasing the duplicates by 1. Otherwise, make duplicates as 0. And now putting the elements, if and only if the number of duplicates was less than or equal to 1, will you be putting the k into that. So increment k by 1, and let's also have the previous to be exactly this, and ultimately just return the k. So now why are we doing doops less than or equal to 1? Don't you think so they needed 2 numbers, right? So they were okay with having 2 zeros. So don't you think doops should be less than or equal to 2? No, because duplicates is anything other than what we already have. So if we already had, if it was same than before, this is the 0th duplicate. So this is the first duplicate. Likewise, this is the 0th duplicate, this is the first duplicate. So similarly, so basically we only need to count duplicates as less than or equal to 1. You cannot have more than 1 duplicate. So we will have k only if that's the duplicates is less than or equal to 1. Any more duplicates, we are not including k. So that is all the Python code, and see you in the next video if I make it. Otherwise there won't be a next video.